My name is Kyle Butler. I am a channel SE for Prisma Cloud, and I work with all of our channel partners on enablement and talking about it. So what I'm going to be sharing with you guys today is not so much Palo Alto's solution. I will give a brief demo and kind of show you a couple different things, but really to more talk about the problems that we are looking to solve. And it's really important to understand that before I really talk about any type of solution. So um, I want to start right here. And I really like this slide because essentially this comes from Gartner research. And this really speaks to the problem space that we're living in today, where essentially what Gartner was able to find is Fortune 500 companies are adding roughly 3.5 new cloud services per day. For people that are working in the cloud or organizations that are looking to take their first couple steps, realize that a single service is not just one asset. It's can sometimes be upwards of hundreds or thousands of different things that are being created with that. And the truth of the matter is, this statistic is already dated, and the acceleration that we are seeing in the marketplace is just steadily increasing every single day. And why that's a challenge is that for organizations that are looking to maintain their compliance postures or understand the vulnerabilities of that, when they're competing against all the different departments within their organization that might be adding these different services, that makes it harder and harder for IT teams and SecOps teams to basically wrap their arms around that and feel confident when they're filling out, attesting to the fact that they are compliant within uh, different regulatory and compliance frameworks. So that's really part of the solution that we're looking to solve for is essentially the amount of adoption in the cloud and the acceleration of that. The other part that I wanted to chat about is essentially the compute continuum. And this is an important thing that I always have a talk about when I'm first talking about Prisma Cloud with the client is understanding this is and it really depends on where your organization sits and on their cloud adoption strategy or maturity level, I would say. So starting on the left-hand side, typically the way most organizations go about adopting a cloud strategy is they'll start kind of with what we'd call a lift and shift model, where they want to dip their toes in. They kind of know, hey, every other organization or my competitors are essentially starting to go to the cloud. So we want to start providing that same kind of thing. So we'll start taking our existing infrastructure and slowly kind of just replicate it right in a cloud environment. It doesn't really matter if it's GCP, AWS, Azure, and so forth. The problem, though, is for organizations that are doing that or in the process of, as you probably started to see, is first off, it's incredibly expensive. So the problem with keeping your infrastructure in a virtual machine state is you're going to be paying for those servers and things, regardless of whether or not they're actually doing anything useful in your environment. At that stage, though, the benefit is that your traditional security tools will work. So you can put like a VM firewall in front of your servers and so forth, as you would on your on-prem infrastructure. But what we typically have seen across the marketplace is that when an organization goes from virtual machines and they do that lift and shift model, the next stage that they're going to start doing is start to actually lower their IT budget a little bit, and they'll start increasing their innovation budgets. And that's where you start bringing in people like essentially like automation engineers, or you might start spinning up a cloud infrastructure practice. And the first thing, if you bring on smart cloud infrastructure engineers and automation engineers, that they're going to look at is say, hey, which of these production applications can we containerize? Because we have to remember, what is the compelling reasons to move to the cloud? The compelling reasons to move to the cloud are pretty simple. The first one is high availability, right? So the ability to serve anybody at any place at any time. That's the first big one. I don't know if anybody on the call has ever worked with like an on-prem high availability group of databases, but I've done implementations in the past where had to work with that type of technology, and it takes an entire team to support that and make sure that it's running for a production environment when it's on-prem. In the cloud, it greatly simplifies that process, and there's a lot of cloud native technologies that you can start leveraging to create high availability for traditional applications that you might be moving to the cloud. The second is unlimited scalability. So you can scale these applications and allow it to grow to meet the demands of your business or your organization at any given point. And that's the other really compelling reason. The problem is, if you're still at the virtual machine level, you can't actually really take advantage of any of those type of technologies. So you'll look to things like containers, and maybe the first thing that you do is you start using some Red Hat virtual machines, and you might stand up a few Docker containers and so forth on there. Now you're going to start seeing the first part of the problem. The first part of the problem is, okay, so when things are running in containers, I don't have any VPC flow logs, or I don't have any insight into how these containers are talking to one another. And I'm going to show you guys a demonstration here in a little bit, but that's one of the first challenges. So the next thing is that, unfortunately, if you are running Docker containers on a virtual machine, again, you're still not able to you might be able to swap the little pieces and services out easily, but you're still not able to really take full advantage of what the cloud has to offer. So that's where you're going to start looking for things like containers as a service. And what that might be called, if you're using like AWS, is a Fargate task, or the serverless environments like ECS, Elastic Container Service, or Azure Container Service, and so forth. So that's really kind of the next stage, is moving those containers from VMs to running in a serverless environment. And the benefit there is now I can start creating these auto scaling groups and so forth, so that these applications can grow and expand, and I really only have to pay for the amount of time that they're running. And once they go down, then it just creates more efficiencies within the organization. The next one is on-demand containers, and that's like Fargate tasks in AWS. And the other part is serverless functions. Another really compelling reason to be in the cloud is essentially the ability to automate everything. And how do you actually automate, different things in the cloud? It's all done through APIs. And one of the benefits of a serverless function is that is essentially what serverless functions are designed to do, is they provide basically the ability to customize an API so that you can feed data from one place into the next without really having to think about what kind of server I need to stand this up on, how much memory, how much RAM, and you're only paying, again, for the time that process lives. So you just write the code, deploy it there. Somebody calls the API, great, you pay for that microsecond that it lives, and it does the thing that it's supposed to do in the environment. Now, those are the good things. The bad things about this is when you get to the stage of containers as a service, or on-demand containers, or serverless functions, traditional security tools don't work for cloud native applications like that. And so if you need to certify whether or not a serverless function like a Lambda function is touching different data in your organization, whether or not it be PCI DSS, so you're focused on like cardholder data, or if you were looking to tackle some of the new privacy regulations that are coming out like CCPA or GDPR, and you need to make sure that the user data or your customer data is being segregated properly from other places in the network, or aren't being used for particular reasons, that can be really difficult for IT teams to try to figure out today. So that's really part of the problem space that we're playing in. So we'll go right here, and this is kind of a nice segue into this, is essentially one of the other things that has shifted a lot in the technology space in the last few years has been the introduction of kind of these disruptive privacy regulations and compliance regulations that organizations aren't used to having to follow. So CCPA, GDPR, we're about to look at, or CCPA 2.0. Really, the benefit is there's a lot of places that you can possibly get data or apply policies and so forth, but realizing that the whole point is we have to be able to attest to the fact that your organization is compliant within these frameworks, even if the technology is rapidly changing. So having that visibility and making sure that you are working with a solution provider who's able to give you actionable intelligence right from the start, because everybody knows they can get a lot of data, but coming up with data that you can actually have insight onto, where you can get like granular information when it relates to the different compliance and security frameworks that you might be working with, is critical to the overall organization's success while they're adopting a cloud native strategy. So thinking about that, that's really where Palo Alto is looking to basically play, is in that space, and just understanding that a firewall company is thinking, hey, we have the best firewall in the industry, but we do realize that if we only support firewalls, then pretty soon with the rapid adoption of different cloud native technologies, if we continue to just sell firewalls, we're not going to probably have a lot of customers to serve in the next couple of years. So Palo Alto is looking at solving this as well as many other players in this marketplace. So I like to kind of highlight this screen as well. This comes from our Unit 42 team, and the quote at the top comes from Gartner. So Gartner found that 81% of cloud users are leveraging two or more cloud providers. Again, that just puts more and more pressure on the existing IT organization or the existing GRC team, when not only now do I need to know all the different things about AWS, but I also might have to support GCP, or I might have to support Azure. And hiring talent that really has a good understanding of those areas is really hard to come by, as I'm sure many are aware. And the other issue is that in those environments, there's an added layer of complexity. And for those of you that have might worked in the cloud, or given demonstrations in the cloud, then you would know that that added complexity is IAM permissioning, trying to figure out like what is the bare minimum of permissions that an application is going to need in order to function properly, but also making sure that you're in line with your zero trust framework that you're trying to implement as well, saying, hey, I'm only going to give the amount of permissions that it needs to fully function, can be incredibly difficult. And with that added layer of complexity comes the chances that essentially the chance for a user misconfiguration just goes up exponentially because of that added layer of complexity. So our Unit 42 team looked at over 200,000 cloud formation templates, literally the building blocks of cloud native applications, and found that of those 200,000, 42% of those cloud formation templates and Terraform files are using insecure defaults. When they looked at the Docker containers that are publicly exposed, 51% of those were using insecure defaults. And a lot of times people get this misconception about a container because they kind of think of it as a miniature virtual machine. The truth of the matter is containers really weren't intended or ever designed to solve security concerns or needs or anything like that. It was really designed to allow for rapid updates, allows you to eliminate race conditions in code. So where you might have different process collisions happening because they're trying to reach the same shared resource, and things like that. The other part is host vulnerabilities. 24% had known vulnerabilities. And how does that happen? Well, again, it's just about visibility and insight into those assets that are getting spun up. It can be really difficult if you are stepping into the cloud for the very first time, trying to figure out, hey, which VPC should I put this in? Which subnet should I be putting this in? And then you have security groups, IAM permissioning, and so forth. So it's very easy to make a quick mistake that could cost a lot in damage later on. So these are some important statistics to keep in mind, because what Palo Alto has done is really looked at the problem space and then tried to go about coming up with a solution for this. So this is a good slide too that kind of talks about where traditional security tools kind of fall apart or aren't able to provide organizations everything that they might need. So we're going to kind of talk about web application firewalls and so forth, but obviously the biggest challenge with a traditional web application firewall is that it's kind of limited on where it can be deployed. So you typically are deploying a web application firewall to protect like a VM or an EC2 instance or something like that. But it is unable to protect against like when those applications become cloud native, like a container or a serverless function and so forth. They might be able to provide you some east to west web traffic, but not within a cluster. And the biggest problem there is it won't scale on demand. So it'll prevent you from being able to basically take advantage of some of the compelling reasons to be in the cloud. A lot of the cloud service providers are going to provide you with WAF functionality. So it's not something that's special to us or anything like that. But there's some limitations again there where it might do the application protection piece, but it might not satisfy what your organization needs when it comes to testifying for compliance, or really being able to provide a compliance lens or a GRC lens through the type of traffics that are going through that. It would allow you to do the scale, but the part that also isn't on here is the fact that if I'm working with Azure's web application firewall, that's not necessarily going to protect me, and it's going to be different for the web application firewall I need to deploy for my assets that are in AWS and so forth. And just realizing there might be parts of my organization that are standing up production applications without even really letting our IT team know about that. So that's another important thing to understand as well. You might have runtime application security protections and so forth, but again, where those tend to fail is when the technology shifts to fully cloud native. And the reason why this is important is that you're partnering with smart people who will allow you to understand that you are future proof, putting a security protocol and practice in place that allows your organization to be security proof the whole way through, and not, or future proof, and not have to go back and tear a bunch of things out because the environment is shifting so rapidly. So um, Palo Alto's way of essentially tackling these challenges that I'm presenting and um, is to essentially what we have done is we've looked at all the best in class players in these different problem areas that we're looking to tackle. And basically our strategy has been to purchase those companies, acquire them, and combine all their technologies into one single unified platform so that there is a common onboarding of resources and allows for single pane of glass for visibility, compliance, and security across every major cloud service provider in the marketplace today. So we started with Redlock and Evident.io. They do cloud security posture management, which is really just a fancy way of saying asset inventory. So tell me all the assets that I have in the cloud. Tell me what the vulnerabilities of those assets might be, and tell me about the compliance posture of those assets. Um, the next phase for our platform was essentially we acquired two other companies, PureSec and Twistlock. And what PureSec and Twistlock brought to the table was really that web application security for next generation cloud native applications. So uh, it can be a little confusing because sometimes the marketing words can get in the way, but what it is really it's about protecting workloads or Kubernetes clusters or Docker containers running in a serverless environment and so forth. We've also started to integrate cloud network security with Aporeto, which helps for compliance as well to understand, hey, what other assets are different Kubernetes clusters and things like that running, able to touch, able to process for data and so forth. And we just incorporated that in February. And the last part is we acquired a company called Bridge Crew. And the reason why we did that is, again, it kind of speaks to just the rapid change of things. Is Bridge Crew was traditionally an open source company. They still maintain an open source tool called Checkoff, and it's going to help enhance our integration points for infrastructure as a code scanning, which is already available on our platform, but also just further enhance it because it has a wide adoption by the dev community, which is a really important part because we've designed our tool in such a way to protect against vulnerabilities during the full software development lifecycle. And some of you might be thinking like, well, why is protecting the software development lifecycle so important? You might have heard the buzzword shift left at certain points. Why that's important is understanding the difference between a native developer or a traditional developer and a cloud native developer, where for a traditional developer, you're typically thinking about like your front end developers who might be running like the web, writing the web applications that people will see, or the back end developers who are connecting all the little pieces on the back end. So they'd be writing code in a traditional environment, and that code would get deployed to, let's say, like a Windows IaaS server or something like that on prem. In that model, traditionally it would be the SecOps team or the IT team's responsibility to ensure that that server is meeting compliance and has all the security protocols in place. They're going to know that thing, know those standards, and know that space inside and out. And it works pretty well in that. But when we start shifting to the cloud, realize that now the developers are not only responsible for writing safe code, they're also going to be responsible for the infrastructure that that code gets deployed on, because now that infrastructure is no longer a server. It might be a Kubernetes cluster running in a serverless environment that's using multiple VPCs or multiple subnets and so forth. And at this point, that's really where our tool comes into play, is because that makes it hard for a security team to say, hey, these are new technologies. These are ones that I haven't been working with for the last 20 years, but I still need to have that visibility. I still need to have some level of control on what type of things are going on in my environment. And that's really why we look to protect the full application development lifecycle. Is we realize that not only checking it when the code's being written, but also when it's being checked in so that it passes QA, we should be checking it there too. We should also be checking it at the repository level and at the registry level, because that code is going to get deployed into a production environment. And it's critical that when we are deploying code like that, that it is going to meet those security standards and compliance standards. So that's really why we incorporated with that, and why it's important to Palo Alto to protect the full application lifecycle. So this kind of just speaks to what I was just saying earlier, but what we've done is basically partner with a lot of different organizations and realize that, does Palo Alto have the 100% answer for everything? No, but we want to work with companies that have large market presence and are market leaders in these different spaces. And what we've done is created tooling and integration points to basically enhance the functionality of the existing technology in organizations' environments. So we can plug into popular IDE platforms like VS Code and IntelliJ. We have integrations with like GitLab, CI tools like Jenkins. We work with the secrets manager, HashiCorp, and work with Terraform files and things like that. And we also do runtime protection and have consent alerts pretty much anywhere that you can imagine. So that's really been our strategy. And just to kind of give you a high level overview of how Palo Alto's solution is put together. And this is, again, not necessarily unique to us, because I'm not trying to sell you Palo Alto, but I do want to have you kind of understand the way these solutions get put together so that you can better understand and protect your organization. So we'll start right here with the cloud workload protection. And essentially, one of the visions for this platform, and is an important consideration for any solution or any organization that's looking for a solution in this type of space, is that that solution should be able to be should be easy to integrate into existing technologies. Because I've done a lot of implementations for a lot of big companies, and I can't tell you a single company that's ever told me, you know what, Kyle, what we really need in our environment is another console, another place for people to check, another place for people to have to go to and check in and try to pull a report from. Nobody wants that. At the end of the day, being able to take a solution and integrate it into the existing workflows and existing technology is critical, because you have to, if people are checking a lot of different areas and having to go to different places for different things, again, it can be just really hard to get an overall picture of what's actually going on in the environment. So we've created a lot of integrations where we can feed into popular SIEM platforms like Splunk or Radar. We work with existing tooling that a dev team might be using, like Jira. We also work with ServiceNow. We do automated remediation plays through Cortex XSOAR, and can basically provide an alert through any one of the popular alerting or communication platforms available today. For cloud security posture management, which is essentially just the asset inventory, compliance reporting, and vulnerability management part of our platform, the way we handle that is very similar to the way that other organizations have gone about tackling this. Is they're always typically an API-driven engine. And what that means, the positives of what that means is that onboarding with a tool like this is incredibly painless, because there's no things that you have to deploy within the infrastructure in order to gain that visibility. They're generally going to be ingesting the resource configurations, the user activity, and the network traffic through the logging that's available through those cloud service providers. So the differentiator between our platform and maybe others out in the marketplace is the wide range of support. So we support AWS, Azure, GCP, Alibaba Cloud. We just added support for Oracle Cloud as well. And the other part is essentially the machine learning algorithms that we feed all this traffic and user activity and resource configurations through in order to provide actionable intelligence. We also have a number of baked out policies that come out of the box with our platform because we realize that you might be able to try to, work with the cloud and use the security centers available with it in your service providers, but the challenge there is not a lot is going to be built out for you, and especially not a lot's going to be built out when it comes to like a compliance objective or trying to meet like a security framework that your organization has embraced or deployed. Those can be challenging. So what we've done to try to alleviate in that space is create a lot of policies out of the box, map those to compliance standards, and map them to mainstream security frameworks as well, so that you can get instant visibility and also actionable intelligence from the platform. Um, for the cloud workload protection piece, it works on what we call an agent architecture, which is very similar to maybe the enterprise antivirus. But the big difference that we have when we say agent, we call them defenders, and really the power of our platform, the cloud workload protection side, is essentially the flexibility of where these defenders can be deployed. Because keep in mind that the cloud workload protection for us is really just cloud native security or application security. And what we're looking to protect is in places that your traditional security tooling can't. So we can deploy it as a container, for example. We can deploy these agents inside of containers. So if you're running them on demand in a Fargate task or something like that, we can also embed them inside of serverless functions. So basically do API protection on all your cloud resources and so forth. How we basically have gone about doing this is incorporating over 30 different intelligence feeds and a number of different machine learning models to basically understand the compliance and vulnerability management of those cloud native applications and whatnot. So the last part is, as I kind of mentioned earlier, we definitely believe in protecting the full application development lifecycle. So we have plugins available, and we've made that very easy to basically access and incorporate into existing workflows that an organization might be running today. So that's really all I have for you guys when it comes to the slide deck. If anybody else that was speaking or on the Red8 team has any comments, I'm happy to discuss it for a second, but then if not, I can also jump into a demonstration and just kind of point out some of the, maybe clear up and show some people on the call some of the vulnerabilities of running things in containers and so forth, and maybe kind of shed some light on that. So
yeah, that would be great. Just a reminder to everybody, if you do have any questions, just please enter those into the chat. But as of right now, Kyle, no questions, so we can hop right into the demo.
All right, great. Okay. So let me pull up my screen right now. And I want to start here. And I might lose some people a little bit on this, but I'm going to try to keep this at a high level as possible because I realize not everybody's going to come from a technical background and so forth. But I think it's important to see this because essentially, again, kind of speaking to the fact that there's a lot of misconceptions about what containers are and the problems that they might solve. But what I'm going to be using today is a container, and I'm going to be kind of explaining it to you as I go, but we'll start at the command line. And what I'm going to do is essentially, I'm going to deploy a Docker container. So I'll kind of walk you through the command once I'm able to finish typing it out. So give me just 1 second. Okay. So I'll dissect this command. This is a command that if somebody's working on containerizing an application, they might be running this on a day-to-day basis as they're testing things out and making sure that they're running properly. What the Docker engine does is essentially, if you're working with the Docker engine, it provides what's called an overlay network. So this is one of the challenges that I spoke about earlier, where trying to figure out like east to west traffic or which containers are talking to other containers and so forth can be challenging because When you deploy a container to that overlay network and I deploy another container on that same overlay network, there's nothing in place from those containers talking to one another. It has its own built-in DNS and so forth. So they can actually reference one another, talk to one another, and so forth. What's important to realize also is you're going to see this part of the command. And what this part of the command is this is the publish port command. So what it essentially does is it maps the port on the host machine to the port on the container. Uh, the reason why I'm bringing this up though is some people will look at this and say, well, that's a security mechanism built in. And effectively what that means is that the containers running on this overlay network can't talk outside of that network on any other port but port 80. That is absolutely not true. And I'm going to show that to you guys right now, but that's the context of this. So the other part is I'm just defining the network it's running on. In this case, I'm using a small Kubernetes cluster called Minikube. Well, it's the orchestrator. And I'm just providing the name as the DVWA, WA1. So I'm going to hit enter. And at this point, I can go to, let's go to localhost setup.php. So for those of you that are not familiar with what this is the DVWA. And what it is it's essentially a web application that's made to be vulnerable, to point out some of the vulnerabilities and teach developers better coding practices and also teach security teams pen testing. Some things that are interesting about the DVWA is that it was written in PHP, and you might be thinking like, I've heard that before, but what is that? PHP is a scripting language, and why it's applicable is over 80% of the internet is written on PHP. So there's a lot of popular sites using it. Examples of that might be like Facebook, Wikipedia, Etsy, any WordPress site. So if your organizations are utilizing that, this is applicable. And what I'm going to show you guys today is a command injection attack, and I'm going to break down what a command injection attack is so you kind of understand it at a high level. Essentially, what a command injection attack does is if the developer wrote a part of their application to execute a command on the shell of the container, if they didn't put proper input validation into what a user puts into the field, then an attacker might be able to insert some additional commands and make it do things that the developer didn't intend it to do. So for this case, this is a pretty simple part of the application. And what the developer wrote this part of the command to do, or part of the application to do, is execute a ping command on whatever IP address you put in here 4 times. So if I put the localhost IP address in here, what you'll see get returned is the same thing that if you ran this from a command line. You'll see a ping coming back 4 times. Pretty innocuous. But what I'm going to do is open up another terminal on my other window, and we're going to run a command injection attack on this, and I'll kind of point out why that's not necessarily the greatest. So here's my laptop and my terminal. And in order to start this attack, what I'm going to do is I'm going to use a tool that's built into every single one of like most of the popular Linux distributions today, and it's called Netcat. And what Netcat does is it allows me to open up a listening port. So I'm just going to pick a random number. We'll pick 9876. And so now on my laptop, I have this port that's open over 9876. And here, as you guys can see, I probably run this demo a couple times. I'm just going to go ahead and flip this over, and we'll go 9876. So 9876. And what I want you to do is pay attention to what happens on the left-hand side of my screen once I hit submit. Okay, so you probably have noticed that something has changed. I have what's now called a reverse shell into the container, and I'll show you why that's bad. It's bad for a number of reasons. The first one is I can start looking at everything that's in the web page, and these might be pieces that the developer never intended me to see. So I can also perform what's called a directory traversal without having to worry about authentication. So I don't need to sign into anything, and I can actually start seeing every part of this application. It kind of gets worse than that though too, because I could also do other malicious activities, like I could make an exploit script and maybe cat a few commands in there. So now if you look here, you can see that here's my exploit file that I just wrote to here, which would not be great. But it also gets even worse than that. And the reason why it's worse than that is it largely comes down to like understanding the technology and really understanding the differences between a container and a VM. In some ways, a VM is maybe more secure. And that's because the primary difference between a container and a virtual machine is that a container will share the same kernel as the host machine that it's deployed to. You might have heard that in a presentation, or maybe this is new information to you, but I'll show you actually specifically some real reasons why that's not great. The first command I'm going to run is called uname. And what uname allows me to do is find out the underlying operating system of the host machine that's running this container. So I can see that the host machine, the virtual machine that this container is running on, is running Ubuntu 20.4, which is luckily the latest release. But if I have a development team that's working on containerizing a legacy application, they might be using an older distribution of Ubuntu or some other Linux variant to write that application on. And it doesn't take a genius to go online and say, hey, tell me about the vulnerabilities of this particular OS, and then maybe get some more attacks from there. Other things that I can do that you might not be aware of is I can see what type of information is being fed to the kernel at boot. So I can tell that this is a VM. I can also do things like find out about the underlying hardware and see what vulnerabilities might be available there. So this is telling me what the host machine's underlying hardware. And I can see right here that this host machine has a processor that's going to be vulnerable to the meltdown vulnerabilities and both Spectre vulnerabilities. So that's not great either. Essentially not a great thing. So how did we go about solving for this? Again, this kind of comes down to our Defender architecture and so forth. So the only configuration I've done in this environment is I've deployed a container defender. And here's why you would want to have a container defender, an application like this, if you're running any type of containers in your environment, is you will be able to see really quickly the vulnerabilities associated with specific container images. And also you can see things like runtime events. So I can see, hey, there was a reverse shell incident that happened, and you're going to want to be able to track things like, hey, tell me about the IP address of the person that connected to this, and tell me what port they were able to communicate over, and even show me things like, hey, I need to see the exact commands this person was running, when this was running, and so forth. And that's critical if we're trying to respond to an incident or a cybersecurity incident and get a hold of it before it spreads further in my network. Those are things that are critical for an organization to understand. Other pieces that we built into our platform is essentially compliance policy mapping. So if you're working on like a PCI DSS initiative, or you follow NIST guidelines in your IT environment, or CIS benchmark standards, those are things that we've mapped out from our policies to those. But that's just kind of a high level of how Palo Alto has gone about protecting what we would call cloud native applications and so forth in the cloud and whatnot. So some of you might be thinking, if you're at that first stage of cloud adoption, that you don't have any serverless functions, or maybe this doesn't apply to you. I learned something when I first joined Palo Alto, which was I was surprised that I'm not a cloud native developer by any stretch of the imagination. I've had some dev experience, but not cloud native. And it was surprising to me because the first thing they had me do at Palo Alto was create an AWS account, create an Azure account, and create a GCP account. And I spun up 3 virtual machines, nothing big, and I turned on CloudTrail in AWS. Well, little did I know, what CloudTrail does is it enables a serverless function across my entire environment. And now you can see, here's all my little serverless functions that I had no idea that I even stood up. So that's the type of thing that can be challenging when we talk about like security or compliance posture in the clouds. And that's why these technologies are relevant, even if you feel like your organization might not be there, is really keeping in mind that you're building your security strategy, your compliance strategies, and so forth for a future-proof or a somewhat future-proof framework, and incorporating technologies that may not seem relevant to you today, but I promise you, if you continue to dive deeper and evolve with your cloud strategy, it's an important thing to keep in mind and important to partner with people like Red8 and so forth. So at this time, that's pretty much all I had to share with you guys today. I'd love to take questions if anybody has them.